In question number 1, 2, 3, choose the correct option and give justification. First question. From a point Q, the length of tangent to the circle is 24 centimeters and the distance of T from the center is 25 centimeters. Then find the radius of circle. Now moving on to solution for the first one. Here, the length of tangent from point Q is given as 24 centimeters. That is, QT is given as 24 centimeters and the distance of T from center is given as 25 centimeters. That is, OT is given as 25 centimeters. Then he asked us to find the radius. Here the radius is nothing but OQ. Now we know that a tangent at point to a circle is always perpendicular to line joining center and that 2 point. Therefore here angle OQT will be equal to 90 degrees, and from this we can say that OQT is right triangle. Now by applying the Pythagoras theorem here, we get OT square is equal to OQ square plus QT square. That implies OT square here is 25 square, that is equal to OQ square, which is nothing but R square, plus QT square is 24 square. That implies 25 square is nothing but 625 is equal to R square plus 24 square is 576, which implies R square is equal to 625 minus 576, that is 45. Therefore we get R is equal to root of 49, that is 7 centimeters. Therefore our option A is correct choice. Now moving on to second question. In figure 10.11, if TP and TQ are two tangents to a circle with center O, so that angle POQ is equal to 110 degrees, then angle PTQ is equal to, now moving on to solution for the second bit. Here angle POQ is given as 110 degrees and asked us to find angle PTQ. Let it be as X. Now we know that at the point of contact the radius is always perpendicular to the tangent. Therefore angle OPT is equal to 90 degrees and also angle OQT is equal to 90 degrees. Now if we observe the figure clearly, we know that a quadrilateral is formed by POQT line segments, that is POQT here is a quadrilateral. In quadrilateral we know that sum of angles is equal to 360 degrees, which implies angle P plus angle O plus angle Q plus angle T is equal to 360 degrees, which implies angle P here is 90 degrees plus angle O is angle POQ, that is 110 degrees, plus angle Q is 90 degrees again, plus angle T is X, which is equal to 360 degrees. That implies 90 plus 90 is 180 and 180 plus 110 is 290. So here left hand side becomes 290 plus X is equal to 360 degrees, which implies X is equal to 360 degrees minus 290 degrees, that is nothing but 70 degrees. Therefore in the second question option B is the 70 degrees and that is our choice. Coming to the third question. If tangents PA and PB from a point P to the circle with center O are inclined to each other at an angle of 80 degrees, then angle POA is equal to, now moving on to solution. Let us consider a circle with two tangents from P are drawn that are PA and PB. Let O be the center of circle. Let us join the OA and OB. Here the angle of inclination of tangents is given as 80 degrees and asked us to find angle POA. Here let us note down the given information, that is angle APB is given as 80 degrees, and we know radius and the tangent are always perpendicular to each other, so we can say angle OAP is equal to angle OBP is equal to 90 degrees. Let us initially find the angle AOB. As we know that AOBP here forms a quadrilateral. Sum of angles in a quadrilateral is equal to 360 degrees, which implies angle A plus angle B plus angle P plus angle AOB is equal to 360 degrees. That implies angle A here is 90 degrees plus angle B here is also 90 degrees plus angle P here is 80 degrees plus angle AOB is equal to 360 degrees, which implies 90 degrees plus 90 degrees is 180 degrees. 180 degrees plus 80 degrees is 260 degrees plus angle AOB is equal to 360 degrees, which implies angle AOB is equal to 360 degrees minus 260 degrees, which is nothing but 100 degrees. If PA and PB are tangents to the circle with center O, then OP bisects angle AOB. Therefore, angle POA will be equal to angle POB, which will be equal to half of angle AOB, since it bisects angle AOB, that is equal to half of angle AOB here is 100 degrees, that is equal to 50 degrees. Therefore, angle POA is equal to 50 degrees. Option A is correct. Moving on to the fourth question. Prove that tangents drawn at the end of the diameter of the circle are parallel. Moving on to solution. Let us consider a circle with the tangents drawn as shown in figure. The circle has center O, and here CD and AB are tangents at ends of diameter. Now, if we consider CD as a tangent, we know that tangent subtends an angle with the radius at the point of contact is 90 degrees. Therefore, here angle OQC is equal to 90 degrees. And if we consider AB as tangent at the point of contact P, AB subtends angle 90 degrees with the OP. Therefore, here angle OPB is equal to 90 degrees. So, as from 1 and 2, we can say that angle OQC is equal to angle OPB. That is, if we consider CD and AB are two lines and PQ as transversal, here alternate angles are equal. Therefore, we can say the lines AB and CD are parallel to each other. Therefore, finally we can conclude that tangents drawn at the ends of diameter are parallel. Now, moving on to a fifth question. Prove that perpendicular at a point of contact to the tangent to a circle passes through the center. Now, moving on to solution. Let us consider a circle with a tangent drawn, and also from the point of contact a line is drawn towards its center. We know that at the point of contact the tangent to a circle is always perpendicular to the radius, and as we know that radius is defined as line joining center and point on the circle, the radius which is perpendicular to tangent at point of contact passes through center. Moving on to sixth question. The length of tangent from a point A at a distance 5 centimeters from the center of the circle is 4 centimeters. Find the radius of the circle. Now moving on to solution. Let us consider a circle with the tangent drawn. Let us consider a circle with center O, and from A tangent is drawn, that is AB. He says that length of tangent from a point A at the distance of 5 centimeters from the center, that is OA here is given as 5 centimeters. So here the length of the tangent of the circle is 4 centimeters. Therefore we can say AB is here given as 4 centimeters. Then he is asking what about the radius, that is nothing but OB. Let it be as R centimeters. So here OA is given as 5 centimeters, AB is given as 4 centimeters. We need to find the OB value. In a circle, we know that tangent is always perpendicular to the radius at the point of contact. Therefore, we can say OB is perpendicular to AB here. That is nothing but angle OBA is equal to 90 degrees. Therefore, by Pythagoras theorem, in triangle OBA or OAB, OA square is equal to AB square plus OB square, which implies OA square is nothing but 5 square, that is equal to AB square, which is nothing but 4 square, plus OB square here is R square. That implies 5 square is 25 and 4 square is 16 plus R square. That implies R square is equal to 25 minus 16, that is nothing but 9, which implies R is equal to root of 9, that is nothing but 3 centimeters. Therefore, the radius of circle given will be 3 centimeters. Moving on to seventh question. Two concentric circles of radii 5 centimeters and 3 centimeters. Find the length of chord of the larger circle which touches the smaller circle. Now moving on to solution. Let us consider two concentric circles, that is with center O, and radius of each of the circles are 3 centimeters and the other one is 5 centimeters. So initially let us know what are concentric circles. We know that concentric circles are the circles which have same center. Therefore here O is the common center for both the concentric circles. The radius of the first concentric circle be R, which is equal to 3 centimeters, and let capital R be 5 centimeters, which is the radius of the larger one, as shown in figure. Now let us consider only the center point O. He is asking length of chord of the larger circle which touches the smaller circle. That means the chord of larger circle that touching the smaller circle will be nothing but the tangent to the smaller circle. So let us draw the tangent to the smaller circle that passes through point P, and let PQ be the chord. let PQ be the chord that touches the smaller circle in one point. Now, the point where chord intersects smaller circle be T. Therefore, T be the point where smaller circle is intersected by chord PQ. Now let us join OT and also join OP and OQ. Now we know that OT is the radius of the smaller circle, that is 3 centimeters, and OP is nothing but the radius of the larger circle, that is 5 centimeters. We know PQ is equal to PT plus TQ, as we know that here OT is bisecting PQ. We can say PQ can be written as 2 times PT. Now if we consider in triangle OPT, OT is perpendicular to PQ, since we know that angle between the radius and the tangent will be 90 degrees. Therefore, now by applying the Pythagoras theorem in OPT triangle, we get OP square is equal to OT square plus PT square. Here we need to find the PT value, which implies OP square here is nothing but 5 square, which is equal to OT square here is nothing but 3 square plus PT square. That implies PT square is equal to 5 square is 25 minus 3 square is 9, that is equal to 16. That implies PT is equal to square root of 16, which is 4 centimeters. But we need to find the PQ length, that is PQ length is equal to 2 times PT, which is nothing but 2 times 4 centimeters, that is nothing but 8 centimeters. Therefore, the required length of chord is 8 centimeters. Moving on to 8th question. A quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. Now moving on to solution. Here, given that ABCD is a quadrilateral and it is circumscribed by a circle which intersected the quadrilateral at points PQRS. If we consider the points separately A, B, C and D, then AS, AP or tangents from point A, PB, BQ or tangents from point B to the circle, and CR and CQ or tangents from the common point C to the circle, and DS and DR are the other two tangents from point D to the circle. We know that lengths of tangents from common point to the circle are equal. Let us initially consider the tangents from point A, that is AS will be equal to AP, comma. If we consider from point B, the tangents are BP and BQ, those lengths will be also equal. And from point C, CR and CQ are tangents, those lengths will be equal. And from D, DS and DQ are tangents, those lengths will be equal. Now initially, let us add the equation number 1, that is AS is equal to AP, and the fourth equation, that is DS is equal to DR. Then we get AS plus DS is equal to AP plus DR, which implies AS plus DS is nothing but, from the figure we get AD. Therefore AD is equal to AP plus DR. Let it be as equation number 1. Now let us also add the second and third equation. Then we get BP plus CR is equal to BQ plus CQ. That implies, on the right hand side if we consider, BQ plus CQ is equal to BC, which is equal to BP plus CR. Let it be as equation number 2. Then we get, let us add equation number 1 and 2. Then we get AD plus BC is equal to AP plus DR plus BP plus CR, which is equal to, let us write AP plus BP together and DR plus CR together, which is equal to AP plus BP. Here from the figure we get it as AB, and DR plus CR from the figure we get it as CD. Therefore finally we get AD plus BC is equal to AB plus CD. Moving on to 9th question. In figure 10.13, xy and x dash y dash are two parallel tangents to the circle with center O and another tangent AB with point of contact C intersecting xy at A and x dash y dash at B. Prove that angle AOB is equal to 90 degrees. Now moving on to solution. Here he has given that xy is parallel to x dash y dash. In between a circle is present with center O, and he also says that a tangent is drawn through point C intersecting xy at A and x dash y dash at B. And finally he asks us to prove that angle AOB is equal to 90 degrees. In order to prove this, let us initially join OC. Now let us consider the two triangles, that is triangle AOP and triangle COA. In these two triangles, angle OPA is equal to angle OCA, that will be equal to 90 degrees, since at the point of contact the tangent and the radius will subtend an angle of 90 degrees. And here in both the triangles we have OA as the common side. Therefore OA will be equal to OA, which is common side in both the triangles. And also OP will be equal to OC, since it is the radius of circle. All the radius from the center to the any point on the circle will be equal. Now hereby side property of congruency, we can say that triangle OPA is congruent to triangle OCA. That is by Sas property of congruency, we can say angle. Therefore by Sas property of congruency we can say triangle OPA is congruent to triangle OCA. We know that when two triangles are congruent, then their corresponding angles and corresponding sides will be equal. That is, here we can equate angle POA in triangle OPA and angle AOC in triangle OAC will be equal. That is, angle POA is equal to angle AOC. Let it be as equation number 1. Now again, let us consider the two triangles, that is triangle OCB and triangle OBQ. Now in triangles, triangle OBC and triangle OBQ, angle OQB will be equal to angle OCB, that will be equal to 90 degrees, since at the point of contact the tangent subtends an angle of 90 degrees with the radius from the center. And also In these both triangles we have common side as OB. That is OB is equal to OB, which is common side for both the triangles. And also OQ will be equal to OC since it is the radius of the circle. Now here again by Sas property of congruency, we can say triangle OBC is congruent to triangle OBQ. When two triangles are congruent, then their corresponding angles and corresponding sides will be equal. Therefore here we can equate angle QOB and angle BOC. That is angle QOB is equal to angle BOC. Let it be as equation number 2. Now if we consider PQ as line segment and O as a point and OC as a ray intersecting PQ at O, then angle POC and angle COQ form a linear pair here. Therefore we know sum of angles that form a linear pair is equal to 180 degrees. We can say here we can say that angle POC plus angle COQ is equal to 180 degrees, which implies here we got in the first equation that we can write angle POC as sum of angles POA and AOC. That is angle POC can be written as angle POA plus angle AOC plus again angle COQ can be written as angle COB plus angle BOQ, which is equal to 180 degrees. That implies here in the first equation we got angle POA is equal to angle AOC. So let us substitute that. That is angle AOC plus angle AOC plus let angle COB remain as it is plus angle BOQ or angle QOB we got it as angle BOC in the equation number 2, which can also be written as angle COB, that is equal to 180 degrees, which implies angle AOC plus angle AOC is nothing but 2 times AOC and angle COB plus angle COB is nothing but 2 times COB. Therefore we get the equation as 2 times AOC plus 2 times COB is equal to 180 degrees. Let us take 2 common here, then we get angle AOC plus angle COB is equal to 180 degrees. That implies angle AOC plus angle COB is equal to 180 by 2, which is nothing but 90 degrees. That implies finally we got that angle AOC plus angle COB is equal to 90 degrees. Let us check in the figure this sum is equal to the which angle. So now moving on to the figure, we see angle AOC plus angle COB is nothing but the whole angle AOB. Therefore here we get angle AOB is equal to 90 degrees. This is what the required proof for us. Moving on to 10th question, prove that angle between the two tangents drawn from the external point to the circle is supplementary to the angle subtended by the line segment joining the point of contact at the center. Now moving on to solution. Let us consider a circle with the tangents drawn and having the center O. Let us draw a circle with center O and tangents AB and AC are drawn from point A to the circle. Now he asks us to prove that angle between the two tangents drawn from the external point, that is angle BAC, and is supplementary to the angle subtended by the line segment joining the points of contact at the center. Here B and C are point of contact. So OB and OC are the lines joining point of contact to the center. He says that angle between tangents, that is angle BAC, is supplementary to angle BOC. That means we need to prove that angle BAC plus angle BOC is equal to 180 degrees. Now we know that in a circle, if a tangents are drawn from external point, each tangent will be perpendicular to the line joining center and the point of contact of the tangent. Therefore here angle ACO is equal to 90 degrees and also angle ABO will be equal to 90 degrees. Now if we observe the figure clearly, here ABOC formed is a quadrilateral. We know sum of angles in a quadrilateral is equal to, we can say here, angle BAC plus angle ABO plus angle BOC plus angle OCA is equal to 360 degrees. That implies angle BAC, let it be as it is, plus angle ABO, which is nothing but 90 degrees, plus angle BOC, let it be as it is, plus angle OCA, which is also nothing but ACO, that is 90 degrees, is equal to 360 degrees. That implies angle BAC plus angle BOC plus 90 plus 90 is nothing but 180 degrees is equal to 360 degrees. That implies angle BAC plus angle BOC is equal to 360 degrees minus 180 degrees, that is nothing but 180 degrees. Therefore, angle between the two tangents is supplementary to the angle subtended by the line segment joining point of contact at the center. This is what the required proof for us. Moving on to 11th question. Prove that parallelogram circumscribing circle is a rhombus. Now moving on to solution. Let us consider a parallelogram PQRS circumscribing a circle as shown in figure. And here the circle is intersecting the parallelogram at 4 points, that is A, B, C, D respectively. Now let us note down the information that PQRS is a parallelogram circumscribing the circle and circle intersecting the parallelogram at the points A, B, C, D. Now let us note down the properties of parallelogram, that is opposite sides are parallel and are equal. Therefore we get PQ is equal to SR and PS is equal to QR. Now if we consider from point S, SA and SD are tangents to the circle. Therefore the lengths of the tangents from an external point to the circle are always of equal length. Therefore AS will be equal to SD. Similarly, if we consider the other points, that is P, Q and R, the lengths of tangents from P, Q and R respectively to the circle will be of equal lengths, that is PA will be equal to PB, that is tangents from the point P, and QB will be equal to QC, tangents to the circle from point Q, and RC is equal to RD, that is tangents to the circle from point R. So now let us add the first two equations. Then we get AS plus PA is equal to SD plus PB, which implies from the figure we get AS plus AP is equal to PS, which is equal to SD plus PB, let it be as it is. Name it as equation number 1. Then let us add the other two equations, that is QB plus RD is equal to QC plus RC, which implies QB plus RD, let it remain as it is, which is equal to QC plus RC. Here is nothing but QR. Let us name it as equation number 2. Now let us add both the equations, then we get PS plus QR is equal to SD plus QB plus PB plus RD, that is equal to, here SD plus RD is equal to RS and QB plus PB is equal to PQ. So we get the solution as PQ plus RS. That implies PS plus QR is equal to PQ plus RS. That implies as PQ is equal to SR and PS is equal to QR, let us substitute them. 2 times PS plus QR, let us replace it by PS, is equal to PQ, let it be replaced by SR, SR plus SR. That implies 2 times PS is equal to 2 times SR, that is nothing but PS is equal to SR. As PS is equal to SR, we can say PQ is equal to SR is equal to PS is equal to QR. Therefore, now in parallelogram PQRS, the adjacent sides are equal. Therefore, PQRS is a rhombus. Finally, we can say that a parallelogram circumscribing circle is nothing but rhombus. Moving on to 12th question. A triangle ABC is drawn to circumscribe a circle of radius 4 cm such that segments BD and DC, into which BC is divided by a point of contact D or of lengths 8 cm and 6 cm respectively. Find AB and AC. Now moving on to solution. Here in triangle ABC, the circle is there, that is nothing but the inner circle. The radius of the inner circle is given as 4 cm. Therefore, let us note down the given dimensions, that is OD is equal to 4 cm, CD is equal to 6 cm and DB is equal to 8 cm. Now let us consider AC is intersecting the circle at point X and AB is intersecting the circle at point Y. Then CX and CD will be tangents to circle from common point C. We know that lengths of the tangents from any external point to the circle are of equal length. Therefore, here CX will be equal to CD, which is nothing but 6 cm. Now, if we consider BD and BY also be the tangents to circle from common point B. Therefore, the length of tangents drawn from any external point to the circle will be of equal length. That is, BD will be equal to BY, which is 8 cm. Now, let us join OX and OY and also AO. Let us also join the CO and OB. Now, as AX and AY are the tangents from common point A, we can say that AX is equal to AY. Let us assume that they are equal to X. Now, let us represent in our figure, that is CX is 6 cm we got, BY is 8 cm we got, and we assumed that AX and AY are XX centimeters respectively. Now let us separately find the area of triangle ABC by using the Heron's formula. Which is equal to, formula we have S into S minus A into S minus B into S minus C, where S is the semi-perimeter of the triangle, that is equal to A plus B plus C by 2. Here small a is equal to BC, small b is equal to CA, and small c is equal to AB respectively. Therefore here we get small a, that is nothing but BC, which is here equal to 6 centimeters plus 8 centimeters, that is nothing but 14, plus B here is nothing but CA or AC, that is x plus 6, plus C here is AB, which is equal to x plus 8 divided by 2, that is equal to, here x plus x is 2x, plus 14 plus 6 is 20, and 20 plus 8 is 28 divided by 2, that is equal to x plus 14. Now area of triangle ABC by using Heron's formula is under root of S here is x plus 14 into S minus A, that is x plus 14 minus BC. Here BC is nothing but 14 centimeters. Therefore x plus 14 minus 14 is nothing but x into S minus B, that is nothing but x plus 14 minus CA is x plus 6, that is 8, into S minus C, that is x plus 14 minus x plus 8, which is 6, that is equal to square root of 8 times 6 is 48 x into x plus 14. Now we can also say that area of triangle ABC can be obtained by adding area of triangle AOC, triangle AOB, and triangle BOC. So let us find them separately. Area of triangle AOB is equal to, as we know that radius is always perpendicular to the tangent, OY will be perpendicular to the side AB. Therefore here area of AOB will be equal to half times base here is AB and height here is OY, that is equal to half times AB here is x plus 8 into OY here is radius, that is 4, which is equal to 2 times x plus 8. Now let us also find the area of triangle AOC, that is equal to half times base here will be AC and height here will be OX, as OX will be perpendicular to AC, that is equal to half times AC is x plus 6 into OX is 4 centimeters, that is equal to 2 into x plus 6. Now area of triangle BOC will be half times base here is BC and height here is OD, that is equal to half times BC here is 14 and OD is 4 centimeters, that is equal to 28. Now we know that area of triangle ABC can be achieved by adding the area of triangle AOB, AOC and BOC. Therefore we get square root of 48x into x plus 14 is equal to 2 into x plus 8 plus 2 into x plus 6 plus 28, that is equal to 2x plus 16 plus 2x plus 12 plus 28, that is equal to 2x plus 2x here is nothing but 4x plus 16 plus 12 is 28 and 28 plus 28 is 56, That implies square root of 48x into x plus 14 is equal to, let us take 4 common here, then we get x plus 14. That implies, let us square it on both sides, then we get 48x into x plus 14 is equal to 4 square, that is 16, and x plus 14 whole square. Here square and this x plus 14 will be cancelled. That implies 48x is equal to 16x plus 16 into 14, let it be as it is, which implies, let us send this 16x to left hand side, then we get 48x minus 16x is 32x, that is equal to 16 into 14. That implies x is equal to 16 into 14 divided by 32, that is equal to, here 16 goes in 32 2 times and 2 goes in 14 7 times. Therefore we got the value of x is equal to 7 centimeters. He asked us to find the lengths of AB and AC. So AB is equal to x plus 6 centimeters, that is equal to 7 plus 6, which is 13 centimeters, and AC is equal to x plus 8, that is equal to 7 centimeters plus 8 centimeters, which is 15 centimeters. Moving on to 13th question. Prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. Now moving on to solution. Let us consider a quadrilateral that is circumscribing a circle as shown in figure, that is here ABCD is a quadrilateral circumscribing circle with center O. Let circle intersect AB, BC, CD and DA sides of the quadrilateral in P, Q, R and S respectively. Now if we join OQ, OR, OS and OP and also join OA, OB, OC and OD as shown in figure. So here we join OP, OQ, OR and OS and also OA, OB, OC and OD. Now here from the point A, AP and AS will be tangents to the circle with center O, and here AP will be perpendicular to OP and AS will be perpendicular to OS. But we know that length of tangents drawn from the common point outside the circle to the circle will be equal. Therefore here AP will be equal to AS as they are the tangents from common point A. Similarly, if we consider the common point as B and BP and BQ as tangents to circle with center O, their lengths will be equal. That is BP is equal to BQ. Similarly, from point C, CQ and CR are tangents. Therefore, those lengths will be equal. And also, from point D, DR and DS are also tangents. Those lengths will be equal. Now, let us name the angles as angle POA as 1, angle AOS as 2, and angle SOD as 3, angle DOR as 4, and angle COR as 5, angle COQ as 6, and angle BOQ as 7, and angle POB as 8. Now we are required to prove that angles subtended by the opposite sides or supplementary. That is, here angle subtended by AD will be sum of angles 2 and 3, and angle subtended by the BC will be angle 6 and angle 7. We need to prove that angle 2 plus angle 3 plus angle 6 plus angle 7 is equal to 180 degrees. And also we need to prove that angle subtended by the other opposite sides, that is AB and CD. AB subtends angle 1 plus angle 8 at the center, plus CD subtends angle 5 and angle 4 at the center. Those sum we need to prove it is equal to 180 degrees. Now let us consider in triangle AOP and triangle AOS, angle OPA is equal to angle OSA. Since at the point of contact, radius subtends an angle of 90 degrees with the tangent, and also OP is equal to OS since it is the radius of the circle, and OA is common side for both the circles, therefore that will be equal in both the circles. Here OA is common side in both the triangles, therefore it will be equal in both the triangles. Now by Sas property of congruency, we can say triangle AOP is congruent to triangle AOS. Therefore, we know that when two triangles are congruent, then their corresponding angles and corresponding sides can be equated. Therefore, here let us equate angle 1 is equal to angle 2. Now, similarly, if we consider the other triangles, that is triangle OSD and triangle ODR, we get angle 3 is equal to angle 4. And in case of triangles COQ and COR, we get angle 5 is equal to angle 6. And in case of triangle QOB and triangle BOP, we get angle 7 is equal to angle 8. Therefore, similarly, we can write angle 3 is equal to angle 4, angle 5 is equal to angle 6, and also angle 7 is equal to angle 8. Now, we know that sum of angles around a closed point or sum of angles in the circle at the center is equal to 360 degrees. Therefore, here we get angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8 is equal to 360 degrees, which implies, let us substitute, instead of 1 we got angle 2, that is angle 2 plus angle 2 plus, let angle 3 remain as it is, and instead of angle 4 we can write here angle 3 plus, and also instead of angle 5 we can write angle 6 here, plus angle 6 let it remain as it is, plus angle 7 let it be as it is, and here we got angle 8 as angle 7, that is equal to 360 degrees, which implies here angle 2 plus angle 2 is 2 times angle 2, and here angle 3 plus angle 3 is 2 times angle 3, angle 6 plus angle 6 is 2 times angle 6, and angle 7 plus angle 7 is 2 times angle 7. Therefore, we get 2 times angle 2 plus angle 3 plus angle 6 plus angle 7 is equal to 360 degrees, which implies angle 2 plus angle 3 plus angle 6 plus angle 7 is equal to 360 degrees by 2, which is 180 degrees. That implies, finally we can write angle 2 plus angle 3 plus angle 6 plus angle 7 is equal to 180 degrees. This is what our first proof. And secondly, we need to prove angle 1 plus angle 8 plus angle 4 plus angle 5 is equal to 180 degrees. In order to prove this, if we consider the equalities, that is angle 1 is equal to angle 2 and angle 3 is equal to angle 4, angle 5 is equal to angle 6 and angle 7 is equal to angle 8, we can say here instead of angle 2 we can write angle 1 plus instead of angle 3 we can write here angle 4 plus instead of angle 6 we can write here angle 5 and instead of angle 7 we can write here angle 8, that is equal to 180 degrees. Now if we interchange the terms, then we get angle 1 plus angle 8 plus angle 4 plus angle 5 is equal to 180 degrees. This is what our second proof required. Therefore, angles obtained by the opposite sides at the center of the circle is supplementary.